Today we're taking notes on the periodic table and classes of elements, more specifically on metals, nonmetals, and metalloids. We're going to be using this sheet to take our notes, as well as your notebook for any other terms that are not in the sheet. So follow along as I read. This is on page 340 and page 341 in the blue physical science textbook. At first glance, you might think studying the periodic table is like trying to explore a thick jungle without a guide. You can easily get lost. However, the table itself contains a lot of information that will help you along the way. Elements are classified as metals, nonmetals, and metalloids according to their properties. The number of electrons in the outer energy level of an atom is one characteristic that helps determine which category of an element belongs. The zigzag line on the periodic table can help you recognize which elements are metals, which are nonmetals, and which are metalloids. So if I look at this, it's not on here, but you should draw. This is where the zigzag line is. It is starts between boron and aluminum. So the first thing I want you to do is here, I want you to draw the zigzag line. Just like it is on the periodic table, you're going to draw that on your note sheet. And already we've said a term. Let's also write how many valence electrons. This is 1, 2. We skip a few. 3, 4, 5, 6, 7, 8. So this is let's write on the front here. These are our valence electrons. These are the very outer electrons. And as the poem says, valence electrons are what you seek at the group number you should peak. So this is the valence electrons. It's not the group number. Metals. Most elements are metals. Metals are found to the left of the zigzag line on the periodic table. So all of these here, here's my zigzag line. All of these are metals. Atoms of most metals have few electrons in their outer energy level. Most metals are solid at room temperature. Mercury, however, is a liquid at room temperature. Some additional information on properties shared by most metals is shown on figure 3. So here is figure 3. And it tells me that metals tend to be shiny. You can see a reflection in a mirror because light reflects off shiny surface of a thin layer of silver behind the glass. Most metals are ductile. That means that they can be drawn into thin wires. All metals are good conductors of electric current. The wires and electrical devices in your home are made of copper. Most metals are malleable, which means they can be flattened with a hammer and will not shatter. Aluminum is flattened into sheets to make cans and foil. Most metals are good conductors of thermal energy. This iron griddle conducts thermal energy from a stovetop to cook your favorite foods. Let's read about nonmetals. Nonmetals are found to the right of the zigzag line on the periodic table. Atoms of most nonmetals have an almost complete set of electrons in their outer level. Atoms of the elements in group 18, the noble gases, have a complete set of electrons. More than half of the nonmetals are gases at room temperature. Many properties of nonmetals are the opposite of the properties of the metals, as shown in Figure 4. So here is group 8, or group 18. They have 8 valence electrons. Nonmetals are malleable or are not malleable or ductile. In fact, solid metals such as carbon and the graphite of a pencil are brittle, which means it will break easily or shatter when hit with a hammer. Nonmetals like sulfur are not shiny, they are dull. Nonmetals are poor conductors of electricity or of thermal energy. If a gap in a spark plug is too wide, the nonmetals, nitrogen and oxygen in the air will stop the spark and a car's engine will not run. Metalloids. They are also called semiconductors, are elements that border the zigzag line on the periodic table. Atoms of metalloids have about half of a complete set of electrons in their outer energy level. Metalloids have some properties of metals and some properties of nonmetals, shown on Figure 5. Beryllium is shiny, but it is brittle and can be easily smashed into a powder. Boron is almost as hard as a diamond, but it's also very brittle. At high temperatures, it's a good conductor of electric current. So let's go to your notes page. And here it says the examples. So we're just going to pick a couple examples from our periodic table that would be in the metals. So if I look at the key, the metals are all of the ones with the blue background. So I'm just going to pick a couple of them and write them. So I'm going to pick calcium is blue. So calcium is going to be one of my examples, and I'm going to write it all out. Calcium is a metal. Let's do, let's come over on this side. Aluminum is a metal. I'm familiar with aluminum. And also let's do tin. Where are these located? Here's the zigzag line. All of my metals are to the left of the zigzag line. So I'm going to write left of zigzag line. Let's look at our properties again. Here where it says the properties of metals. Metals are shiny. They are ductile, which means it can be turned into a wire. They are good conductors of electric current. They're also good conductors of thermal energy, but good conductors is going to be a good conductor of electric and thermal. We're also going to say that it's malleable, which means that this is what it's a picture of the tin foil here, the aluminum foil. It can be flattened into sheets. Okay, let's look at metalloids. I go over to my periodic table. Metalloids have the green background. These are the ones that are on the zigzag line. So I'm going to use, for my examples, I'm going to write boron. Let's do silicon. And let's do germanium. Location, they are on the zigzag line. These right here. properties of metalloids on page 341. They can be shiny, but brittle. And they can also be hard, but also brittle. And then last one, at high temperatures, good conductor. Okay, our last one, let's look at nonmetals. Our nonmetals are going to be all of these with the yellow. Nonmetals, yellow. Nonmetals, yellow. So I have some that are in a gas form, some are still solids. Let's say that nitrogen, you can choose any three, but nitrogen is a nonmetal, chlorine is a nonmetal, and let's say krypton. You can choose any of the ones that are yellow and write those down for your examples. Where is this on the periodic table? These are the ones all to the right of the zigzag line. Okay, let's look at our properties. So nonmetals are not malleable or ductile. So they can't be turned into wires or flattened. So not malleable or ductile. They are not shiny. And they are poor conductors of thermal energy and poor conductors of electric current. So we can just write poor conductors.